In this video, we are going to be learning about using function notation, and in particular, we are going to practice a little bit of evaluating functions, plugging in different values into different functions. So let's just start by describing what function notation looks like and what the different parts of the notation, what they are called. So if y is a function of x, we often use function notation to describe the function. Instead of y equals 3x minus 5, we write f of x equals 3x minus 5. And notice how we say f of x, right? That's how we name that function. That's how we read this notation. All right, so a couple things. The name of the function will be the letter. So in this case, the function's name is f. It could also be g or h, or really even a Greek letter like phi. The value of the independent variable goes inside the parentheses. The defining expression is the rule that that function follows. It's on the other side of the equal sign from the name of the function. And then taken all together, the name along with the parentheses, along with the independent variable, all of that together is the value of the function. And that's the same as if we had, you could express that as y or f of x. And y and f of x are often used interchangeably when we are talking about functions. All right, so now that we have the basics, let's go ahead and do a couple examples. And so we're going to practice just evaluating a few functions. Let's start with number 19. So for number 19, we know that f of x is equal to 7x minus 3, and we want to evaluate it for x equals 4. So what we do is everywhere we see an x, and I like to put it right underneath it, anywhere I see an x in this entire equation, I'm just going to replace it with 4. So first I replace it right here. And then remember, 7x, that's the same as 7 times x, so I'll change that to 7 times 4 minus 3. And so again, just notice everywhere I had an x, I replaced it with a 4. Once I've done that, now I just evaluate 7 times 4 minus 3 using the order of operations. I'm going to do the multiplication first. 7 times 4 is 28. Bring down the minus and the 3, and 28 minus 3 is 25. And we are done. You can also, if you have a calculator handy, you can just put this in your calculator right away and skip the step below. All right, let's do the next problem. Number 20. Here we have g of x is equal to negative x squared plus 6x minus 8. And we're actually going to do two different problems. First, we'll do A, where we're going to find g of 5. That means we are letting x equal 5. So again, everywhere I see an x, I am going to replace it with the number 5 that x is equal to. So this will be g of 5 is equal to negative 5 squared plus 6 times 5 minus 8. And now I'm going to evaluate this. Again, if you do have your calculator, you can probably just plug it in, but let's pretend you don't have a calculator. How do we evaluate this? Well, remember, the order of operations is parentheses, then exponents. We don't have any parentheses, but we do have exponents, so we'll do the exponents first, and that's going to be 5 squared. And one thing that's important, that negative 5 squared is different when it's written like this compared to if it's written like this. Negative 5 squared is equal to negative 5 times negative 5, which is equal to 25. But negative 5 squared, and I'll maybe move it over a little bit, is actually equal to negative, and you do the 5 times 5 first. And 5 times 5 is 25, so this is just going to be negative 25. So a very important distinction between if the negative is, if you have a negative 5 squared like this, or if you have a negative 5 in parentheses squared. So this will be negative 25. And so parentheses, then exponents, and next will be multiplication. So we'll multiply 6 times 5, which is 30. And now I'm just going to add and subtract going from left to right. So negative 5 plus 30 is positive 5, minus 8 is negative 3. And I am done. I do have my calculator here, so I'm going to check my work just to make sure I didn't make any mistakes, but it looks like I did it correctly. Let's do part B. Now, one thing that I suggest whenever I always like writing down the function first, even if I've already written down before, because I really like just replacing every x with whatever x is equal to. And I like to do it vertically. So in this case, since we're finding the g of p, we're going to let x equal to p. Now this is a little bit different, but we can do this. It's not too complicated. And it's really, we're going to follow the same process that we followed when x was equal to a number. So this is going to be g of p. Everywhere we see an x, we are going to replace it with p at this time. So this would be negative p squared plus 6 times p minus 8. Now, this cannot be simplified. None of these are like terms on the right-hand side, so we are actually done. And that is part B. All right. So let's go ahead and do number 21. 21 is an interesting one, but again, the process will be exactly the same. First, we're going to write down what the function is. And notice in this time we're trying to find the h of n plus 8. That means we are going to let x equal n plus 8. So anywhere that I see an x, I'm going to replace it with n plus 8. So this would be h of n plus 8 is equal to 5 times, and I need to replace it with n plus 8. Now, one thing that is very important here is we want to multiply 5 times the whole quantity n plus 8, not just 5 times n. So we want to put parentheses around this. And so notice everywhere we saw an x, we replace it with n plus 8. Now here, we can simplify this because we can use the distributive property. So 5 times n is 5n. 5 times 8 is 40 plus 6. And then I can combine these two number terms. 40 plus 6 is 46. And so this is what h of n plus 8 is equal to. Let's go back to the slideshow. And we're going to do a couple more examples. I need to copy and paste them very quickly. All right, here our functions are not expressed as equations, but we can still use function notation. In number 22, we are trying to find the f of 5, and our function is expressed as a set of ordered pairs. So what we have here is we want to let x equal 5, since we're trying to find f of 5. And so we want to find the ordered pair where x is equal to 5. That would be this one right here. And this tells me that when x is equal to 5, y is equal to negative 25. And remember, y is interchangeable with f of x. And so f of 5 must be equal to negative 25. When I plug in the input of 5, I get the output of negative 25. And I am done with this one. For number 23, we have the graph of a function. Our function is being expressed as a graph. And so for part A, we want to find what is g of negative 2. Again, this means that here we are going to let x equal negative 2. So I'm going to go to the x-axis. I'm going to find negative 2. And I'm going to go either straight up or straight down in this case until I hit the graph of my function, and it's right at this point. Now this point is negative 2 comma negative 1. And so that means that when my input is negative 2 in this function, my output is negative 1. So g of negative 2 is equal to negative 1. For part B, we have a slightly different problem. Here we are trying to figure out for what input do we have the output as negative 5. In other words, for what x value is the y value equal to negative 5. So let's find our y value of, so here again, we're basically going to let y equal negative 5, and we're going to try to find the x value that goes with it. So if y is equal to negative 5, I'm going to go to 5 on the y-axis. And here I'm going to draw my line straight to the right until it hits my graph. And then we can see that the point positive 6, negative 5 is on the graph of my function. This means that g of 6 is equal to negative 5. So when x is equal to 6, g of x is equal to negative 5. And we're pretty much done. I think you could express your answer. I kind of express this in two different ways. Either one of them is a perfectly fine way to express this answer. I think we're going to do one more example. So let's go back and find the last example. Here we have an equation, and we want to express it using function notation, using f of x instead of y. Once we do that, we want to find, okay, when my input is negative 5, what is the output of my function? So step 1, I'm going to solve for y. So I'm going to get y by itself on one side of the equal sign. So how do I do that? I'm going to write down my equation first. And I'm going to think to myself, I need to get rid of the x, and I need to get rid of the 5. One thing I'm going to do here, and often I'll write down, like, if I want to get rid of that x, I need to subtract that x. A lot of times when we're solving equations, we do it underneath it. But to me, it's a little bit awkward because these are not like terms, and it could be a little bit confusing. So another way I think about this is there's a general rule that says I can move anything from one side of the equal sign to the other side as long as I change the sign. So if it starts positive on one side of the equal sign, it will become negative on the other side. Or if it starts negative on one side of the equal sign, it will become positive on the other side. So I'm going to take that positive x and I'm just going to move it to the right hand side and make it negative. So the x is going to disappear from the left. I'll be left with negative 5y equals the 8 will stay here, and my positive x gets moved to the right and becomes a negative x. Next, I need to get rid of that negative 5. So I am going to divide both sides by negative 5. When we divide this, I'm going to do a fraction bar underneath the entire right-hand side. On the left-hand side, these negative 5s cancel out, and we are left with x equals 8 minus x divided by negative 5. And this is a perfectly, we have solved for y. Y is all by itself. Next step is we just replace y with f of x. So I'm going to do just that. On the left-hand side, instead of y, I'm going to write down f of x equals, and it'll be 8 minus x divided by negative 5. So I have taken this function and I have expressed it in using function notation. These are just two different ways of expressing the same function. In the second way, now we have it expressed as in function notation. Next, let's find f of negative 5. So I'm going to rewrite our function in function notation. And I'm going to plug in, I'm going to replace x with negative 5. One thing that is important here is notice that this minus that's right here is already there. So this will be a minus, and then when I replace the x with negative 5, I'm actually going to get another negative. I end up with a double negative here. So make sure whenever you plug in a negative number, if there's already a minus sign before it, you'll end up with a double negative. Divided by negative 5. And remember, a double negative is the same as adding. So when you subtract a negative, that's the same as adding. And 8 plus 5 is 12 divided by negative 5. That's a perfectly good fraction. Often, though, we like to put the negative sign either in the numerator or just next to. So you could put the negative in the numerator. That's probably a better way to do it. Another option is you can just put the negative right at the fraction bar. I would be fine with all three of these, but you will usually see one of these two options when we're trying to express the number negative 12 fifths. Okay? All right, and that ends this video. We'll see you in the next one.